Hello again, Year 8s. This is the third learning intention for being assessed in this energy topic. You need to be able to understand and describe the relationship between gravitational potential energy and kinetic energy. And to do that, you've got a few formulas to apply to the questions. Let's go straight to the formulas, and mostly you will be asked to explain these concepts using mathematics. So ensure that you bring a calculator to the test. So let's have a look firstly, just in the order that we've done it in class. Initially we'll look at the gravitational potential energy and how to calculate that and rearrange the formula, and then we'll look at how to calculate kinetic energy. So zoom forwards to page 13. Gone way too far. Gravitational potential energy. So this could be expressed as GPE or just simply EP, so potential energy. The basic equation we will give you in your test, you just need to apply the values in the question to the equation and work out the unknown value. Please remember, and I wish that I could throw stars at the screen, remember to use units. So energy is always in joules or kilojoules or megajoules, but in joules. And notice the other units used in the question. So this formula can only be applied if the mass is measured in kilos, if the distance or height is measured in meters, and gravity is in newtons, which it always will be. If you have millimeters, centimeters, kilometers, you need to convert it into meters before you apply it to the formula. Take gravity. The gravity will probably be given to you in the question. And if it states the gravity is 9.8, you need to use 9.8. If it's not stated and you need to use gravity as 10, that will be okay on this occasion. But keep in mind that gravity on Earth is 9.8 newtons because it's a force. Okay, so looking at the question, first thing is to rearrange the question, ensuring that you have the unknown value. You've rearranged it so that you can calculate the unknown value, and use the triangle to do this. So for example, if you need to calculate height, and I'm going to use the whiteboard here, so hopefully you can see that I've drawn the triangle here behind me. If you need to calculate height, and you actually have the value of potential energy given to you in joules, you have the mass and you have the gravity at 9.8 newtons, what you need to do is rearrange this by covering up the H and then doing your energy divided by mass times the gravity. So that's what it looks like. Height equals the potential energy that you're given in joules divided by, and then remember to calculate this first, mass times the gravity. So whatever mass you're given in kilograms multiplied by the gravity there, 9.8, and then do your energy divided by that, and that will give you your height in meters. Now the same thing can be applied if you're looking for the height in meters. Sorry, the mass. So you can cover this one up and you do energy divided by gravity times height, and that will give you your mass in kilograms. Remember the units. Remember to show you're working. Apply the same principles to your kinetic energy calculations. So you'll find those written on page 18, which is here. And once again, so kinetic energy is written as KE, and kinetic energy is calculated by doing 0.5 or half times the mass times the velocity squared. So the first thing to do is calculate the velocity squared, multiply that by the mass, and then multiply by 0.5. And that's how to do it. And rearrange using the same principle as we've described with gravitational potential energy, ensuring that you have the unknown here and the known values on the other side. Okay, well done.